my name is Allie West, and this is my lab number 4 on oscillations. So, quick introduction. The purpose of this lab is to demonstrate the motion of a spring mass system with d mass oscillating in an arc. I will be using Tracker for the experimental position, which will be like the real-life video where I track the motion. And then I will be using GlowScript to find data for a predicted position, which will be a coded version of the model of the motion of the spring. The goal is to evaluate how well the computational model represents the energy principle, and that means that the system's total energy should remain at a constant zero, demonstrating that the energy principle is true. So here are the principles that are demonstrated. First of all, Newton's second law, or the variation of it specifically that will be used here is the momentum principle, which is here. Also, the energy principle, of course, which states that the system's change in energy is the sum of work done by surroundings and thermal energy exchanged with the surroundings. So this here, change in E equals W plus Q. And then finally, I'll be using update formulas, position and velocity, as usual, and then these are different formulas for the different types of energy. So here is the observed motion, or the real-life video, where I track the position as the spring changes. So this is from Tracker. I'll play it again. You can see how it's changing, and then each of these red points are demonstrated or are shown here in these two charts for X and Y position, and you can see how they change. Also, these are all my initial conditions, and initial conditions continued here for T, K, and L naught. Basically that's the experimental part of this lab. And then moving into the computational model, I used some of this data from the experiential model to input into the computational model. So the initial position here, and then also input all the other information or data that I have. So G, the spring constant, L naught, initial velocity, which was 0 because it doesn't start moving, and then the mass of the ball. So this is my code, or the remainder of my code for the computational model, which again I use GlowScript for. So basically, first I have to define all the energies, then I have to calculate each of the types of energies with those formulas, so like gravity, spring, and net force is the sum of those two. Then I have to use the position and velocity update formulas to apply the momentum principle. And then I'll have to calculate all those changes in energy down here. So, yeah, and then again I have to recompute all of these energies over here. And then this chart shows basically how all the energies change over time. So that there's kinetic energy, gravitational energy, and spring energy, and then also change in energy is this orange line right here that's flat. So comparing the computational and observed models, this is the red dot here is the experiential model actually. So you can see how it's a little bit different from this coded model, which is the blue. I'll play it again. And then again in these charts, the red is from the video I showed earlier, and then the blue is from the computational model. So is the energy principle satisfied? The answer is yes, because we can see in this chart that the total energy is constantly at 0. Even though the other energies change, like you could really see that here with the green, which is the change in the spring energy, the sum of all the energies stays the same, which is this orange line. You see how it's just flat and it's at 0? That shows that there are no external forces acting on the system, and therefore the energy principle is true. Also, comparing the X and Y oscillation periods. So different directions will have different periods, so their spring constants will be different, and therefore so will their graphs. So you can see the difference here. It's not super noticeable, but if you look like down here at this red, then you can really see how the Y graph is different from the X graph over here. Possible errors. So the model doesn't exactly reflect reality, because in reality the system is not closed, so work can be done from the surroundings. That's why there's kind of a difference between in the video and on these charts, the red and the blue, because the real is different from the computational model. Another possible error is human error. So like when I'm manually marking each position in Tracker, like it's not a computer doing that. So like I may not be entirely accurate as I'm tracking each position. But yeah, overall, I'd say it pretty clearly shows that the energy principle is true. The lab went pretty well. It pretty much shows what it's supposed to, and yeah, you can pretty clearly see like how the motion is charted. So yeah, thank you.